Sign from the producer. So greetings, let's get started. Certainly a warm welcome to Pioneer's Surface Engineering Academy's webinar series. I'm David Jilot, your host, market leader for Pioneer's Commercial Industrial Products segment. And sitting certainly more than 6 feet from me, he's had his temperature checked, he's feeling great. He's bringing a lot of energy today. He's our corporate product manager with 30 plus years of experience, Steve Goodsett.
Morning, Dave.
Morning, Steve. Certainly a lot of design content to share with you today, but before we get into that, I want to take a moment to set this webinar series up. Really, why are we doing this? Born out of the COVID era as a means to connect with our customers. We recognized we needed to do something different. We couldn't sit across the desk from you, couldn't review projects in person, review samples, discuss designs, and we really saw an opportunity for distance learning, an opportunity to share 75 years of learned surface engineering experience in an accessible format available right on our website. There you can find white papers, short technical videos, performance data, etc. So we'd encourage you to visit the Surface Engineering Academy warehouse. More on that at the end of the presentation and where you can find that. But the fact is we're all tired of COVID. We really are. We want to continue to operate safely while also being mindful and protective of our 1,300 plus employees. I can't help, Steve, but acknowledge and really take point of the feeling that we're on the cusp of a manufacturing boom. Similar to what we saw in the 1950s, it sure feels like that. Whether that materializes is TBD. But it begs the question, as a manufacturing community, are we ready? Are we ready to support this economic recovery? Are we ready as supply chain partners? Are we communicating effectively, working together, thinking about design verticals correctly so that we can make better products, more cost-effective products that compete on a global stage? So really, we have one goal with this seminar and these webinars. It's to educate. So hopefully along the way, we encourage you to think a little bit differently about different projects that may require surface engineering, surface finishing. Maybe there's a project you passed on or a project that didn't go so well. Perhaps we're non-competitive on. We would encourage you to reach out or to think differently about that. Or maybe there's something you learned from one of our webinar series that would help get you over that finish line. Occasionally, we hope to entertain you, whether intentionally or unintentionally. And then one last disclaimer, we've started our webinar topics intentionally broad, and I promise we'll ramp up the complexity and the specificity of the topics themselves and get into more complex and focused narrow topics. But to get started, we'll be talking today about design considerations for aluminum. Our next webinar is on June 26th. That's on plating considerations, or I should say design considerations for plating. And then in July, we'll talk more about automotive design considerations, and gets into more adhesives and automotive-driven finishes. Much more exciting news down the road with manufacturing thought leaders joining us, as well as some of the hot topics of the day with respect to life science finishes, antimicrobial finishes, active coatings in the healthcare space. One final note, we'll take questions at the end of the seminar and get more interactive and specific to the audience's projects. So hang with us there. From a question perspective, there will be an interactive session at the end. So to get started, just an outline of the agenda today. We'll talk briefly about aluminum and its capabilities. Won't beleaguer you on the subject of aluminum, but we really want to focus on the performance requirements of programs that are tailored towards aluminum surface engineering. Whether those are functional, aesthetic, or overall execution requirements, we'll get into that. We want to talk about manufacturing feasibility and alloy selection and how that all aligns with your intended outcomes, and certainly the finishes that are available for the aluminum market. We'll talk about chromate conversion coatings, for example, anodic coatings, different platings, and overall organic coatings. So we'll be sure to connect the dots. We won't have time to get into each and every finish and the subtle nuances or the performance criteria of each finish available for aluminum. Much more about that is available at the Academy warehouse, but certainly would be open to then also follow-up discussions tailored towards your specific needs. So to set this up again, just a brief overview, why aluminum? Well, first off, it's lightweight. The weight to strength ratio of aluminum is substantial. We look at whether it's fuel savings, overall efficiencies. The weight of aluminum is attractive, of course. It's flexible, it machines well. There's been a number of advancements in technology regarding aluminum. For example, the 7050 alloy that's recently emerged purported to have the same strength as steel at a third of the weight. So you can look at what's maybe happened to the steel market here in the US, and there's plenty of talk about that, and whether that's been shipped overseas perhaps, but we'd be remiss, Steve, if we didn't mention the rise of aluminum. And you can see in some of the charts we've provided here, over the past 20 years, the demand for aluminum has doubled both in the automotive space as well as just overall demand. So it really begs the question in terms of supplier selection and setup, and the need for a capable supplier of aluminum surface engineered finishes. A capable partner that offers differentiating products, can manage color, manage chemistry, deliver on time, and at the end of the day, after you add all the value to the products, not destroy parts at the end of the supply chain. That's a big problem, obviously. So to get started and really to help us gauge what brought the audience to us today, a quick interactive poll. So the question being, what performance attributes are the greatest priority in your design world as you sit here today? We've given you some selections. You can choose multiple options. You should see a pop-up on your Zoom platform. And again, overall, just the ability to tailor content, tailor some of our answers in the question and answer session, really to maybe what's out there from a challenge perspective. So just give it a moment, and responses are filling in. I see looks like a mix of responses relative to wear, corrosion, aesthetics. Okay. All right. Well, excellent. Looks like we've got 20 plus responses. So thank you. Thank you. Appreciate that. Let's dive further into the technical details, though. So design considerations and overall performance attributes. So Steve, I'm going to lean on you for this, but the functional attributes or functional performance attributes, I should say, for coating systems, surface engineered systems. Talk to us a little bit about that in terms of you're at the design phase. What are you setting out to do with the product you're designing?
Yep. So you decided to use aluminum, and as Dave pointed out, there's different types of mechanisms you can use to provide enhanced performance from this aluminum. Your primary concern with these parts might be wear resistance. And as Dave also mentioned, aluminum unfortunately is a lot softer than steel. It will wear easier. But Pioneer has, and many other metal finishers have solutions such as anodizing. Anodizing is an electrochemical conversion coating. It can take the soft aluminum and convert the surface to aluminum oxide. Aluminum oxide has the same hardness as a diamond. So now we can take the soft part and make it very wear resistant. Or corrosion resistance might be the primary attribute that you're looking for. There's organic coatings such as paint that do a very good job, but anodizing also does a great job for providing good corrosion protection to the aluminum. One of the main advantages of anodizing, though, over a paint type of a coating is it is converting the aluminum to aluminum oxide. It's becoming an integral part of the surface, and it's hard, so you can't scratch through it, and you don't have the issues with creep corrosion that you have.
Corrosion, yep. Yeah, grown from the base layer. So
you can also provide different coatings that will make the part slippery for lubricity, a combination of a smooth finish and then also something that's naturally slippery. PTFE type materials do a great job. We've got anodized coatings that incorporate the PTFE. We've also got coatings that are plated that have co-deposition of PTFE, electrolytic nickel coatings, for example. Your primary concern would be, I need to take this conductive piece of aluminum and make sure it doesn't conduct electricity. I need to make it dielectric or non-conductive. Anodizing and organic paint type coatings do a great job of making the part non-conductive. You might need it to be very UV stable for performance reasons. A shift in the color could affect how the part performs. You might need a very dark coating because, example with cookware, you're trying to get the best thermal transfer from the coating, and you're looking for a dark colored, hard anodized coating, for example.
So that's functional, not all of the functional performance drivers, but the common ones. Talk to us a little bit about the aesthetic drivers and making sure we incorporate the desired look of the part in the design.
Well, whether you want your aluminum to be its natural silvery look or you want different colors added to it, it's important to look at different things about the aluminum than you would with paint. Organic coatings will go over the top of the base metal, and you can provide a shiny paint or a dull paint. You can provide the exact color that you need. When you're looking at anodizing, it's really important to understand that if you have a shiny base metal, you're going to get a shiny reflective anodized part. The opposite being that if the part has a very rough finish, a dull looking part will be produced. And the reflectivity has an impact on how it looks to you. The more reflective the finish is, the shinier the part's going to be. And then overall, you want to make sure that this color isn't going to change as it's exposed to either outdoor lighting or indoor lighting. Both can have an impact. We look at making sure that we're measuring what that color shift is as we expose it to the ultraviolet light as a method to identify the color stability.
So Steve, the functional aesthetic drivers really are closely linked to the alloy selection as well. So important because some of the alloy series aren't going to allow flexibility or achievement of the functional or aesthetic desired outcomes. And so important to know that up front when you go about designing your product, what all lines up from not only performance desirables, but also overall manufacturing feasibility. Can those be achieved with the alloy that you intend to make the part from? So talk to us a little bit about alloy series.
So like we were talking about, Dave, it's important to understand what the part needs to do. And if you're going to use aluminum and you're picking a coating such as anodizing, what impact will the type of aluminum that you're using have on the performance of that anodized coating? The alloy series of aluminum are going to be the aluminums that can be made into sheet metal or extruded through a shape or forged into a shape. There's basically 7 different series, and they go through the 1000 through 7000 series. The 1000 series of aluminum is 99.9% pure aluminum. The advantage to that being that there's no alloying metals put in the aluminum, and when you anodize it, you get a very clear silver appearance to it. The 2000 series of aluminum is usually used because it has a great ability to machine without wearing out tools. The downside to that aluminum, though, is the copper metal is added to it to improve the machinability. And copper is not necessarily a good friend for the anodizing process. There's a potential for burning, lower thicknesses are achieved, lower wear resistance, less corrosion. The 3000 series of aluminum is made into sheet metal, works very well for stamping products, spinning products. The 4000 series of aluminum, we don't see parts made out of that. No, it's made for welding rod to do manufacturing. 5000 series aluminum does a great job again. It's for making stamped products. It's made into sheet metal. The alloy series we see most common at our metal finishing plants, so it's the 6000 series of aluminum. 6000 series aluminum can be extruded, can be made into sheet metal, can be forged. It can be designed to have good machinability. It can be designed to even be cast into a shape.
Yeah, Mike 6, for example, right?
Yeah. 7000 series is designed for strength, as you mentioned, the 750 alloy series. Zinc is used as the alloying metal. Have to be a little bit careful with that. It still does a great job as far as corrosion and wear resistance, but it can have some issues if you try to put too thick of a coating on. Then when we switch from the alloys that are either sheet metal or extrusions, we get into the castings. Now, a casting can be a great tool, especially for our customers, because you can eliminate a lot of machining by casting the part into the main shape. Unfortunately, though, some of the castings have a lot of other metals in them. It's not just a singular alloying element. Porosity is more common. The two main types of castings are to pour the casting or to do high-speed injection die-cast type materials.
Right, and with casting, Steve, you typically get a lower thickness potential, right? So corrosion resistance, wear resistance reduced. There's ways to overcome that. There's a couple of proprietary finishes, CastGuard and EnduraGuard, that are out there that can really boost corrosion prevention, or corrosion protection, I should say. But overall, the attractiveness of a casting, sure, on the cost side, but overall performance could be a concern.
Right, and as you mentioned with those proprietary type coatings, now our customers can take the advantage of the lower cost of casting a part, and still, in the example of CastGuard, get up to 1,000 hours of salt spray, which is unheard of.
Absolutely. Absolutely. So real quick then, a slide to illustrate the oxide layer formed by the different alloy series in anodic coatings. So again, specific to anodic coatings, but important to note here in the oxide coloration itself. So grown from the base metal, the oxide layer itself can have a dramatic impact on the color that you're trying to achieve. If you're dyeing the part, or if you simply want to leave it undyed, know that the oxide layer will produce different impacts. You see that most likely if you're using 7000 series, as the thickness increases of an anodic layer, a greenish effect will emerge, and that's really the zinc coming out in the alloying consistency.
You know, and that aesthetic impact can also be seen when you do an overdye. So if you look at the chart at 1000's thickness of anodizing, you get different hues. And if you use these different alloys together and try to make all the parts blue, for example, you get a little bit different shade or a little bit different hue of blue based on the alloy.
Same can be said, and we touched on the 2000 series alloy and its limitations as well as cast, but 2000 series with copper not being able to produce a real thick, a 2 mil, say mil 8625 requirement type hard coat, and therefore your wear resistance, your corrosion resistance potential is limited. So something to consider as you go about selecting alloys and considering the cost impact, the machinability, and everything that aligns vertically with the desired outcome of the part. So really to kind of wrap this up, so we've talked about the functional and aesthetic desirable outcomes. We've talked about how alloy plays a role in that. We're kind of at that point, Steve, where now it's time to select a coating system, if you will.
Yes.
And I know this chart here that's on the screen for the audience may be a bit of an eye chart, but the majority of the finishes that we would recommend for aluminum products, as well as a few others that we maybe don't offer or offer in very limited fashion as proprietary products, but really getting to the point where taking all of those factors, functional, aesthetic, alloy, cost, manufacturing feasibility into account, and rolling that into a choice for the coating that you're looking for. Walk us through, Steve, some of the characteristics here in the chart, knowing that you have functional up the y-axis and aesthetic performance up the x-axis.
Yep. Well, as you can see on the functional side of it, we've noted type 3 anodizing. Type 3 anodizing can produce a coating that has wear resistance equal to 70 Rockwell steel. So there's a great, that's a great coating for wear resistance. We've also got the CastGuard that I alluded to, where we can allow our customers to save costs by casting the part and now produce high corrosion resistance on a casting. We also have an anodizing process that we call optical black. The optical black is a functional coating in that standard anodizing is done with organic colorants. This is an inorganic colorant that when it's exposed to high intensity light, even laser type lighting, it doesn't break the color down. So from a functional reason, that's critical. We have our EnduraGuard coating, which was primarily designed for castings. With that process, we've been able to provide an anodizing, again, that doesn't have the creep corrosion that can hold up to thousands of hours of salt spray. It's been approved for marine applications in salt water. We've also got the standard type 2 anodizing. Now, type 2 anodizing has wear similar to steel, yet we can provide all the different bright colors. We can do the bright dip where it has a very nice translucent appearance to it, and it's not going to scratch off like paint does. Precious metals. Many times people think of gold and silver plating as something aesthetic, right, for jewelry, but it's a very functional coating. Precious metals are the most passive. They have the highest corrosion resistance, and they have awesome conductivity. Chromate conversion now is going to be getting where it's not really great standalone for salt spray.
Really a primer, yeah.
But it does a great job for the organic coatings as a pre-treatment so that you get the adhesion to the aluminum. Zinc plating now is going from a barrier type protection for corrosion to sacrificial corrosion. It also can be painted. It has a lot of good attributes. If the parts are going to be prone to being damaged and scratched, having a sacrificial coating does a great job. We offer standard electroplated nickel, but we also have the specialty electroless nickel plating. Electroless nickel plating can come in a variety of flavors. Some of it is as wear resistant as hard chrome plating, and we've got versions that will have thousands of hours of salt spray. We also have a version called Norlube that incorporates PTFE right into the coating. So now I have something that's not only slippery like a PTFE coating, but it has the wear resistance of a steel. And then painting, organic, whether it's powder coating, spray coating, or e-coating, sure, they do a great job for salt spray corrosion and consistent coloration.
Yeah. Now, again, overall, we could probably have individual webinars on each of these coatings or categories of coatings. And so I know, being mindful of time, we're fortunate that you're gracious enough to spend a half hour of your time with us today. Don't have time to get into all of the exact performance characteristics of each of those coatings. Steve mentioned a number of those, whether it be the hardness aspect or wear resistance, corrosion, salt spray rating. I'll assure you that all of those particular tech data sheets and available technical information are located on our website at the Surface Engineering Academy, as well as other sections designated and devoted right to those finishes themselves. Always happy to talk further about that, test panels, provide that technical information. If you believe one finish is more desirable than the other and you're settled on that, happy to walk through those performance criteria. Steve, anything else to add with respect to the finishes here?
I'm looking forward to the questions, Dave.
Yeah. So again, just a quick blurb about the Surface Engineering Academy, where you can find additional information. There's white papers, there's videos, short technical presentations pertaining to subjects like anodizing or electroless nickel plating, the benefits of hard coat anodizing, and when hard coat is not truly hard coat versus a true 32-degree 2 mil hard coat. So a whole lot more info that can be found there. Would encourage you to check that out. We'll continue to add more info and data, more white papers, videos, etc. to that particular location. You can access it through the link here on the screen, or find it at the top of our website in the Navigator banner, so to speak. So with that said, I want to take a moment and set up the question and answer session. I know we breezed through and really touched the surface of a lot of these topics today, Steve, and so had to keep the subject matter broad in the interest of time. You'll see a question and answer icon in the Zoom platform. You're able to submit questions and answers right to the audience as well as to the presenters here. We'll do our best to answer them here in real time. And then if there's anything that you'd want to follow up with after, by all means, able to do that. So first question that comes in is, how will anodizing impact the dimensions of a part? So I think we need to think about that in type 2 and type 3 aspects, Steve. So
yes. So as I mentioned, anodizing is an electrolytic conversion coating. We're using the base aluminum to make the coating. So as it's forming, it's penetrating into the base metal and growing out from the base metal. The two main types of anodizing. Type 2 anodizing, about 30% of the coating is going to be growth, and the remaining 70% is penetration. So if I was going to put thousands of anodizing on, I would approximately change the dimension 3/10,000ths of an inch per side. Now, hard anodizing, type 3 anodizing, is closer to about 50% growth, 50% penetration. So do need to keep that in mind when you're looking at parts that have tighter tolerances.
Planning for extra dimensional growth, but not like a plating where if you asked for 2 mil, you get a full 2 mil growth per surface.
Correct.
So again,
Correct.
70% penetration, 30% growth for type 2, and then 50-50 for the type 3 hard coat.
Correct.
Excellent. Really kind of sets us up for the next question, and that is, what about reworking or repairing anodize of 70-75? So strip and rework, really a delicate subject in terms of having to remove the initial coating and remove the material.
Right. So this kind of just leads from the last question of, if I put 2 mil of hard anodizing on a part, I've got half of it penetrated into the base metal. Anodizing is a non-conductive coating. That's one of the challenges. We're using electricity to form the coating, but as we make the coating, it's making the part non-conductive. So to re-anodize, we have to get back down to the raw aluminum. If we're going to remove the coating, we have to take all the coating that was penetrated into the base metal off. Now the size of the part has changed because of that. And there's also a maximum amount of anodizing that can be put back on a part because of the fact of it being a non-conductive coating. In general, 3/1000ths, depending on the alloy, is about the maximum that can be grown back on the part. Now, as far as repairing an area, there is some ability to have just selective areas machined off and expose the raw aluminum and then go back and start the process over again. You have to be careful though, because if you get near the point where the old thickness was of the coating, you can start attacking that old coating. So it was something that can be done, but quite frankly, it would be risky. Yes.
Yeah. Next question. Maintaining a consistent color seems to be a challenge for anodized product, dyed product specifically. What tactics does Pioneer employ to help control color?
Well, you kind of have to go back to how do you make the part colored to understand how to control it. When we do anodizing, it's not like paint where you have an organic coating with a certain pigment to it and you're applying it over the base metal. When we make color anodizing, we take advantage of this aluminum oxide that we're forming having porosity, and we impregnate this porosity with a dye. So the more porosity, the depth of the porosity, the darker the color that we can make the part. One of the things we've got to make sure that we're doing then to control the color is have the thickness very uniform from part to part and the porosity of the coating be very consistent. After that, it goes back into really controlling the chemistry, making sure that the dye is in good shape. We measure those chemicals with a spectrophotometer, but we've also used the spectrophotometer for measuring the color of the parts too, to make sure that we're meeting the requirements that were set out. From somebody's eye, we turn that into a number as far as what the actual color is.
Yeah, and I would also refer you to the Academy website. There's a short video there pertaining to color that goes in depth on that very subject. Seems to be a hot button in the marketplace. Next question, can you provide some examples of products that would utilize PTFE coatings?
So we were talking about anodizing. We have two different versions that can take this hard coating, specifically the type 3 anodizing, and impregnate the surface with PTFE. One version is the hard lube, which will provide the best wear and lubricity. And then we've also got the Tough coating, which provides great corrosion protection and lubricity. We also can, as I mentioned before, co-deposit the PTFE into electrolytic nickel coatings. And then you get the advantage of not only the slipperiness that comes from PTFE, but also the hardness of the electrolytic nickel coating for long wear. And we also offer direct PTFE coatings applied right onto the steel base.
Sure, dry lube, for example. Yeah, so think about applications though, high cycle, metal to metal type contact, whether that be surface friction, surface wear, anti-galling, And really the lubricity factor serves as a force multiplier for hardness in the wear resistance equation. We see advantages not only of having a hard coating, but also a slippery coating.
That's your best wear resistance, is that combination.
So metal to metal scenarios, and not even both metals needing to be aluminum, perhaps a steel and aluminum interface where you'd want to protect that softer aluminum. Next question. Does Pioneer offer electroless nickel with PTFE plating options in black? Ooh, that's an interesting one, and have had plenty of inquiries pertaining to black nickel, different colored nickel platings.
We have had success with taking the co-deposit EM and Teflon and then applying a electrolytic black nickel over the top of that.
Would like to talk more about that. It's a recent request I've seen as well. Black nickel is a product offering we have. It's not often we see the PTFE component, but it can be done.
Yep, I'm aware of a process.
Yeah.
A few customers out in our Portland facility doing that.
Next question. Do you offer bronze plating on 6000 series aluminum? If so, would it need to have a diffusion layer? Parts for an MRI environment where plating layers such as nickel are allowed because of not allowed because of magnetic properties. So the bronze being somewhat of a magnetic insulation.
Yeah, we don't offer bronze plating, but as far as magnetic insulation, we do offer the electroless nickel, the high phos electroless nickel for our Norgard. That's a non-magnetic coating. I don't know if that would meet this requirement. Looks like Jason wrote into us. We'll have to get back to you on that, Jason.
Next question. Do you test and validate your coatings?
Yes, we do. So as far as what's really critical from an operations standpoint is understanding all the different inputs that have an impact and all the synergies that are involved, whether that's control of the chemistry, whether that's control in the dwell times and the different tanks, the temperatures. We have formal control plans that we've developed over the 50 years we've been in business. And then we go and measure the outputs that are critical, whether that's wear resistance, corrosion protection, the thickness range that's required. That's done not only on a job-by-job basis, but we also do performance testing to make sure that no matter whose parts come in, when we say we're going to do type 3 hard coat, we're going to meet the wear resistance requirements. In many cases, we have the military specifications as our background for our performance testing, but we've got numerous customers that have requirements specific to their
monthly panel testing, for example, whether it be salt spray or coupons for Tabor or Suga abrasion testing, all designed to comply with, say, MIL 8625 or MIL 26074, for example, on the electroless nickel side.
Dave, you got these specs down.
But panel testing, yeah. So next question, Steve. Is it possible to selectively plate the ID of a short 6-inch long aluminum tube and hard coat anodize the OD of the same tube?
Yeah, that's a combination we've done in the past, and that's where electroless nickel comes in, where you can do the hard anodizing on the OD, and then we could mask the OD off and then do the electroless nickel on the inside, because you don't need the electricity to make electrical contact. And
for the nickel plating process.
And as long as the solution can flow, that electroless nickel will deposit.
You touched on a good subject there, masking, obviously a critical part in design. We didn't get to that today in the presentation. Certainly something that's a daily event in our world, extensive masking, tape, paint, plugs, custom design fixtures, but yes, certainly possible, Jason, thank you. Next question, are there different versions or ratios of Norlube plating with more or less lubricity, in essence playing with the percentages, if you will, of the PTFE?
We don't do that. We hold the maximum level of PTFE in the coating, which is in that 20% range. Trying to change that would not work well as far as the integrity of the chemistry, but we have other methods of taking that coating and having it be more corrosion resistant or more wear resistance without altering the PTFE.
It could be done, but it would require a separate bath, so to speak, or a separate process tank,
but we
different than what we have today.
but we think we can do the adjustments that would be needed for more wear, more corrosion by keeping the Teflon content, PTFE content consistent.
Fair enough. Next question, can you discuss the dielectric properties of anodize? How would this be applied?
So anodizing, by its nature, aluminum oxide is non-conductive, as I mentioned. The thicker that oxide is and the denser that oxide is, the better the dielectric strength is. And then how well you seal the porosity up, again, enhances the non-conductive nature of it. In general, though, wrought alloys where you can put on a type 3 hard coat to a 2000s thickness and then seal that will provide the best dielectric strength. The rule of thumb is you want to see at least 1000 volts of DC electrical resistance.
Excellent, excellent. Next question. Do you also offer FDA compliant hard coat?
The hard anodizing, by its nature, aluminum oxide is considered safe for direct food contact by the FDA. So the answer would be yes.
Yeah, I guess the only watch out there maybe on the dyed side, as well as some of the sealing technologies, making sure that we're not injecting or applying something that may violate FDA requirements.
When you start dyeing the aluminum oxide, then you move from direct food contact into indirect food contact.
Excellent, excellent. Okay.
One more
question incoming, it sounds like, and if there's more, we'll certainly take them. We'll
get back
keep going, but yeah, some great questions, quite frankly, some great questions.
Excellent.
Next question would be, what's the smallest ID of a tube that you could apply hard coat anodize to?
inside diameter.
Yep.
Well, in general, it's a combination of not only the diameter, but the depth. And the rule of thumb is that we don't want to see a diameter that's less than 25% of the depth. So if you start getting a very long, thin blind hole, then you're going to have issues with solution flowing and the electricity flowing. But normally, in general, when you get beyond less than a quarter inch, you don't want to see a hole that's longer than 3 inches.
Right. So there's a ratio typically that we would look at, Steve. What do we typically target there with getting hard coat down into the ID of the tube and the
Don't
ratio?
remember the exact number, but it is documented.
It's about
Somebody got me here.
That's a good question, but yeah, we definitely anytime we see the need to drive coating down into the ID of the tube on the anodized side, looking at whether it's ID cathodes or means to get that electrical current down into the tube or into the ID and really build the coating. But there definitely is a concern and a limitation that we need to be considering up front at design. And then question again pertaining to FDA, good one. Do we offer FDA certifications for our anodize?
We don't offer a formal certification. We offer a compliance.
So a statement of compliance.
Correct.
So both anodize and hard coat, correct?
Correct.
Okay, and then again, having to watch the dye and the seal requirements. Right. Typically a hot water seal, and then when we get into some of the nickel-based seals, we have to be careful there, or sodium dichromate.
Right. You know, and the FDA isn't just food applications, so there are some variations there. When you do get into food, then the NSF, the National Sanitation Foundation, also gets involved, and they would give the actual approval to the product.
On the whole product.
The whole product, including
the coating.
And we would provide whatever information is required for that.
And same can be said with some of the electroless nickel offerings as well regarding FDA and NSF approval.
Yep.
Excellent, excellent. Getting the sign, there are no more questions. That doesn't mean there may be some you're holding back. Happy to take those in an individual basis, but really wanted to thank everyone for joining us today. Inaugural kickoff webinar, and appreciate the time spent. Hopefully it was valuable. We'll look forward to feedback, and again, building out some more content for you, not only in the Surface Engineering Academy, but also in subsequent webinars, and really driving towards more narrow and complex subject matter moving forward. But this was a great start from a high level perspective for aluminum coatings. So Hope you enjoy the rest of your day. It's Friday. Enjoy the weekend. And again, thanks for joining us.
Thank you.